Section 3.4 has a couple of very important ideas, but it's a short section, and it focuses on, it says the title is right triangles. And in the very first proof, doesn't involve right triangles at all. This is true for all triangles. And this is where we have a parallel segment joining the midpoints, right? The midpoints here, D and E, are midpoints of two sides of the triangle. And if they are midpoints, then the segment that joins them is parallel to the third side. And it's also 1/2 the length of the third side of the triangle. You're like, well, okay, that's great, but this isn't right triangle um, geometry yet. And fair enough, but I will point out that Theorem 4 is going to establish the properties of a 30, 60, 90 right triangle, including the 1:2 square root of 3 ratio of its side lengths. And you'll notice that this is the 1/2 the length of the hypotenuse. So there's connecting ideas here in how we're finding the how we're developing the ideas of these right triangles. Okay. There's also a rather stunning implication here from Theorem 1, and this is actually, frankly, quite crazy if you think about it. If I take the midpoints of any quadrilateral, okay, so quadrilateral just means four sides. I take any four-sided polygon, find the midpoints of all four of its sides, join them, and I will get a parallelogram no matter what. There's no way to draw a quadrilateral so that its midpoints don't form the vertices of a parallelogram. I put convex here to make it easier to prove. It's true even for concave, but I didn't want to make life miserable, and a lot of people don't even think of the concave case. So there's that simplification, and the final result in this section is a proof that I did, which is the similarity proof of the Pythagorean theorem. And that relies on the fact that we have this self-similarity property of any right triangle. And so let me draw a right triangle here. And the idea is that if I draw an altitude from the right angle, from the vertex at the right angle to the hypotenuse, then both of the small triangles created, triangle 1 and triangle 2, are similar to the original triangle. That's true in every right triangle. Every right triangle, just start at the right angle, draw an altitude over to the hypotenuse, and you'll have three similar triangles. So those are some key results. Very important to remember this self-similarity property. It's one of the key properties of right triangles, and not sort of, but it's the linchpin of this section.